Hi, this is Soman. So today I'm going to deliver a talk on the name reaction. This is so in this video I'll talk about only only five name reaction, which is one is the Cannizzaro reaction, another is the crossed Cannizzaro reaction, and third is the Parkin condensation, fourth is the Benjamin condensation, and fifth is the Tishanku reaction. So coming to the first reaction, this is the Cannizzaro reaction. So what is Cannizzaro reaction? So just 1 minute. Yes. So in this introduction part today I am going to explain five name reaction. One is the Cannizzaro reaction, second one is the crossed Cannizzaro reaction, third is the Parkin condensation, and fifth is the Tishanku reaction. So coming to the what is Cannizzaro reaction. So one can think of this if we start with this aldehyde to suppose it is a intermolecular aldehyde, intramolecular. If you take one aldehyde, you will end up getting alcohol, primary alcohol, as well as the acid in the presence of sodium hydroxide, and with the help of this just simple workup, acidic workup. So if you see the and coming to the next, what is you'll come to the later what is the mechanism of this Cannizzaro reaction. Coming to the another Cannizzaro reaction, this is also part of this Cannizzaro reaction. What is the cross Cannizzaro reaction? Like in the previous case we have seen this only two same type of aldehyde if we take, then we can end up getting the same type of only one alcohol, primary alcohol, and one is the acid. So if we take the two different aldehyde like benzaldehyde and formaldehyde in the presence of the sodium hydroxide 30%, and with the simple acidic workup, you can end up getting the formic acid and as well as the benzyl alcohol as the product. Now coming to the mechanism, how this Cannizzaro reaction is happening actually. So as I already told you in this previous slide, that in the presence of the base we are using 30% of the sodium hydroxide. So in this reaction aldehyde, where the carbon act as a electrophilic center and OH minus act as a nucleophile, then OH minus will attack to this electrophilic center of this aldehyde, where this O minus will then this the next state what will happen, one will be the OH and another in this reaction which are also base, it is there OH minus, then it will deprotonate this OH protons, then it will come O minus, then this O minus, this arrow, this resonance will happen, then this H act as a hydride source. So if you see from the starting where this carbon act as a where this carbon is a electrophilic center, now it's become act as a nucleophile. So it is you can say also it is a Ampoulang reactivity. So this carbon showing it is the Ampoulang reactivity. So you can also assume that in this Cannizzaro reaction the carbon act as a Ampoulang. Carbon shows the Ampoulang reactivity. So what will happen? Then this hydride will attack to this aldehyde, to carbonyl carbon. Then there will be formation of this acetate, means acid, as well as the primary alcohol with the simple acidic workup with this H3O plus or H3O plus, then you can end up getting a primary alcohol as well as the acid. Now coming to the another important name reaction, this is the Parkin condensation. So what is Parkin condensation? In this name reaction, if you see this is a name reaction, but in this organic reaction one can start with a aldehyde, benzaldehyde, let's say for an example benzaldehyde, in the presence of acetic anhydride and in the presence of sodium acetate as a base, you can end up getting alpha beta unsaturated aldehyde and acetic acid as a byproduct. Now coming to this example of this Parkin condensation, means you can say it is a application. So coumarin, it is a very good natural product, we know this is a very good important one natural products. So one can also synthesize this coumarin molecule in this with the help of this Perkin condensation. So one can start to synthesis this coumarin. One can start with the sodium salt of salicylaldehyde, and in the presence of acetic anhydride and sodium acetate as a base, and where you can end up getting coumarin as a your expected product, and with the very small amount of the acetic acid as a byproduct. Now, coming to the mechanism of Perkin condensation, we know that Perkin condensation is a very important reaction where you can end up getting this alpha beta unsaturated aldehyde. Now, if you see the mechanism where acetic anhydride as a we are using for acetic anhydride, so how this reaction is happening? In the presence of the sodium acetate, it will first extract the proton of this acetic anhydride, then it will form an acetate enolate ion formation, and followed by aldol condensation with this aldehyde. You can end up getting this cyclics in this O minus CH2 COO COCH3, where this intermolecular acyl transfer will happen. Then you can end up getting this cyclic type transition state, cyclic type intermediate, where this O minus again it will come back, and you will get this O acylated ester type molecule, where again it will this O minus will attack to this acetic anhydride. Then one of the acetates will comes out from this reaction, and followed by the E2 elimination in the presence of the OH minus. You can end up getting this alpha beta unsaturated ester type molecule. Also, we have in this reaction mixture acetate as a base, so as well as a nucleophile, where this acetate will attack there. Then you can, and with the help of this acetic workup, you will get this alpha beta unsaturated carboxylic acid also. So in this Perkin condensation, you can also get aldehyde as well as the alpha beta unsaturated carboxylic acid. Now we come to this next name reaction. What is the another important name reaction is the benzene condensation, where one can start with this benzaldehyde, aromatic aldehyde, in the presence of the sodium cyanide, water and ethanol as a react as a sodium cyanide, water and ethanol in the presence of, you can end up getting benzoin. This is alpha keto alcohol. And if you see the mechanism of this benzene condensation, what will happen in the presence of sodium cyanide, where Cn minus act as a nucleophile and the benzaldehyde carbon act as a electrophilic center. This Cn minus will attack to this carbonyl carbon, then O minus will generate, then O minus will extract this proton from the water, then it will generate a means pH CHOH CN. This is like a nitrile type intermediate, where this H is acidic enough, where OH minus can easily take the proton of this CH2, and there will be one resonance type with this means conjugation with this cyanide. It will form a nitrile enolate, where this enolate again this this is also Ampolang reaction. It will also, this carbon act as also Ampolang reactivity, will show Ampolang reactivity, where in the presence of this another aldehyde, sure, it can again attack to this aldehyde carbon center, where you can end up getting this OPH OHCN CO minus pH, where this in the presence of this base it will extract this proton, and this Cn minus will comes out, where we know that Cn minus act as a good leaving group. Then you can end up getting this benzene product. Now we coming to the next name reaction. What is Tishenko name reaction? Tishenko reaction. In this case, in this reaction, you can't imagine, this is a good name reaction as well as the good synthetic application it has. If someone start with this acetaldehyde, you can end up getting this ethyl acetate, which act as a solvent. Then how this reaction will happen? This is like a important, very important reaction in organic, in pharmaceutical as well as the industrial basis. If you see the application of this Tishanku reaction, this Tishanku reaction is happening in the presence of this metal alkoxide, like aluminium trialkoxide, maybe OR, it is OET, aluminium triethoxide. Okay, sure. If we see the mechanism of this reaction, where, okay, another example, if we also start with this propionyl dihyde and suppose any R2CHO, then you can end up getting this like beta hydroxyaldehyde, and Tishanku reaction, in the presence of Tishanku reaction, you will get alpha beta acetate alcohol, this type of molecule. And this is and if you come to the mechanism of this Tishanku reaction, you can see where we know that how this, if you see the mechanism how this reaction is going, we know that aldehyde carbon is not that much electrophilic. So where one means this reaction is happening with the help of the two equivalent of the aldehyde, right? So one aldehyde cannot attack to this another aldehyde, where oxygen acts as a nucleophile and carbon act as a electrophile. So this can only happen if there will be some driving force, so that driving force or some factor which can increase, which can increase the electrophilic center to this aldehyde carbon. So in the presence of this alkoxide, it will increase the electrophilic center of this aldehyde group, where it will then another aldehyde oxygen can easily attack to this carbonyl center, then carbonyl center, then this oxygen will attack to this carbonyl center, where like here, sorry, this then this hydrogen attack will happen to here, then it will form a cyclic 6-member cyclic transition state, where then only you can end up getting this hydrate this ethyl acetate if you start with this acetaldehyde. Okay, so thank you for this time, and I'll come with this next video with some interesting name reaction in the part 2, my part 2 video. Thanks for the viewing, and subscribe my channel.